Good afternoon. So, if you remember, I talked about these kinds of functions. I want to solve some more problems and then we switch to the new topic. So, the topic will be applications of trigonometric functions. But let us review what we learned before. So, I talked about these kinds of functions: a sine something in the box plus b cosine something in the box. So we learned that we can reverse engineer this to write it as the original form of this using the addition formula for sine. And then we learned that y can be written as square root of a squared plus b squared. And then sine of whatever inside the box plus a constant c. And the constant c is actually tangent inverse of b over a. So this is of course working for a positive. I also gave you an example what you're supposed to do if a is negative. Yes? Okay, so let us solve some of the problems in the book and then we just continue to the next part. Okay, so for example, there are some simple questions, so I don't want to distract you with these very simple questions. So hopefully you understand this problem is also the same thing we have. Yes, we want to find the amplitude of this function. Okay, so you see that what if I ask you in this problem here, if I ask you what a is the coefficient of sine, which is 4, and b is the coefficient of cosine, which is 3. So this is a and b. And then if I ask you what are a and b in this problem, what are they? 1/2 and 1/2, yes, because that is just, so these are simple, okay? So let us, for example, go to this problem. Okay, here a function of this form is given to you. You are supposed to design to fine-tune this a's in a way that the maximum of this function becomes 1. Okay, that is also very simple, hopefully, yes. So if the function is of this form, a, is it cosine first, sine first, sine x plus cosine x, and the maximum is given here to you, which is 1, and you are supposed to find a. Okay, so what should I do? I write it in this form. So I multiply a in, it becomes a sine x plus a cosine x. So here, both a and b are equal to the same number. On the other hand, I know the maximum. So what is the maximum of this function? We solved some problems of this before. So the maximum is this number, the minimum is negative of this number, yes? So they are telling us the maximum is supposed to be 1. So y maximum is the square root of this number to power 2 plus that number to power 2. But on the other hand, y maximum is given to be 1. So this becomes 1. A squared plus a squared becomes 2a squared. And then I want to get rid of a square root sign, so I raise it to power 2. It becomes 1 equals to 2a squared. And then let me write here. So a squared becomes 1/2. And I am looking for a, so a becomes plus or minus 1 over the square root of 2. So this is the this is the answer that you have to provide for this problem. So that was also very simple, yes? Okay, so let us, for example, try to understand this problem. This is also very simple. A function is given to you in this form. You are supposed to write it in this form. So to be honest, this is not the new lesson. The new lesson is that the function is given in this form. You want to reverse engineer and write it in that form. So going from this form to this form was what we learned actually in addition formula. Okay, but they just want you to see what is it going. So let us just do that. So if a function f of x is given to be 2 sine x plus 45 degrees, and I want to write it in this form, we just need to use the addition formula, corresponding addition formula here. So what I do, I would write f of x is equal to 2, and then I use the addition formula for sine of the sum of two angles. So it becomes sine of the first one multiplied by cosine of the second one plus the other way around. Sine the second one and cosine of the first one. Yes? But this number is famous. It is the square root of 2 over 2. And this number is also the same here. And then I have a 2 here. So when I multiply 2, this 2 that I multiply will cancel these 2's in the denominators. And then I will get f of x is equal to square root of 2 sine x plus square root of 2 cosine x. So that's the answer. So in this case, both a and b are equal, and they are equal to the square root of 2. Okay, so I don't think these problems are hard, but I would say that these two last problems are good to investigate here. We want to solve these equations. Okay, the reason, of course, because the lesson here is related to this formula that you see here, you might have this clue that this problem is supposed to be solved using this lesson. But I want you to understand that, for example, at the end of the semester, if you are supposed to solve this problem, you need to remind yourself that, okay, this problem is related to this lesson. How should you understand that? Because when you see the left-hand side is a function of this 4, in which a is 1, b is also 1. For example, the second one, which is more interesting, is of this type. This a is 3, this b is a square root of 7. So I'm just telling you that this is important to realize, because most of the time, if the problem is supposed to be solved using this method, there will be no other methods that you can use to solve it, or they might be much more longer. So this is why that I want to draw your attention that to understand the pattern. Whenever you have a combination of sine and cosine with powers of 1 with the same angle in front of them, you need to remind yourself about this lesson. Okay? I will solve the first one myself, then I give you time a little bit to solve the second one, and then we go to the next lesson. Okay, so the first one, I want to solve an equation, yes? Sine x plus cosine x equals to 1. I want to solve this equation. I want to find all numbers x. So let me work in radians, for example. The first thing that comes to mind, because this is of this form, I use this idea, so I use the formula sheet and then I write this. So how should I do that? First, a is 1 in this problem, b is also 1. So I calculate square root of a squared plus b squared because that is needed. So this becomes 1 squared plus 1 squared, 1 plus 1, 2, so it becomes square root of 2. And then I need to calculate c. c is tangent inverse of b over a, but b and a are both equal to 1. So this becomes tangent inverse of 1, and this 1 is famous. I have it in my memory. It becomes 45 degrees. If you decide to work in radians, we write it pi over 4. And then you use the formula to rewrite the left-hand side, okay? So how should I write the left-hand side? The left-hand side is the square root of 2 sine of the box. The box here is x, and then plus capital C. With the capital C, I got it to be pi over 4 equals to 1. And this is a standard problem, so hopefully you know how to solve that, yes? I have sine. This is a standard because I want to put sine equals to a number, so it motivates you to divide everything by square root of 2, which becomes 1 over square root of 2. And then do you remember? This angle is sine inverse of this plus 2n pi. Another option is that this is equal to pi minus sine inverse plus 2n pi. So I have two options, yes? Either x plus pi over 4 is equal to sine inverse of that. This is a famous number. Sine inverse of that is 45 degrees or pi over 4 plus 2n pi. But then this pi over 4 and that pi over 4 are cancelled, so x becomes 2n pi. This is one option that I have. The other scenario is that x plus pi over 4 is equal to pi minus this number, then plus 2n pi, and then I move pi over 4 to the other side. It becomes minus pi over 2 pi, it becomes pi over 2. So x becomes pi over 2 plus 2n pi. So these are my solutions, and of course n belongs to C. Yes? Okay, that's it. But for the second one, I want to wait for you a little bit. I think at some point you might need a calculator. Let us solve this one. I want to compare it with the solution in the book. Let me see if this book has written it in radians or in degree. Let us wait a little bit. So they have answered this 360 degrees times n and 90 degrees plus 360 degrees plus r. Okay, so let us solve that problem also in degree mode so that we can compare our answers against the answers provided by the authors. Okay, so I want to wait for you that you can solve. At some point to calculate C, you might need your calculator. So switch your or the GeoGebra, if it is in front of you, you can use that, but do it in degree mode. Okay, so hopefully you will able to answer that. Yes, so what we do here, A in this problem. So again, that I'm just trying to draw your attention. What is important is that remember this combination for the final exam. Okay, here we know that this somehow should be related to what I taught you, but you have to keep it in mind that whenever you see this combination, might be, I don't know, might be in the exam, this is given on the other side. But these are small minor changes, so you need to understand that you have to compare it with this one. Okay, so A is 3 in this problem, B is square root of 7, and then, so what happens for a square root of A squared plus B squared, which is a square root of 3 to power 2 plus square root of 7 to power 2. At least this is simple, because this is 7, this is 9, square root of 16 is 4, yes? That is simple. But this one probably we need approximations. So if it is in the exam and I haven't give you access to the calculator, of course you can just write the number as it is, okay? You don't need to do anything, you just plug C there. Or you can write C and say C is this number, okay? But if the calculator is allowed, so let us just do this using GeoGebra. So where is tangent inverse? I think here. So we go to f of x and choose tangent inverse, and I think in algebra view it is automatically in degree mode, yes? So I would write square root of, oh, where is the virtual keyboard? You know, this GeoGebra drives me crazy, you know, sometimes. So, it's here. Okay, now it goes square root of 7, and then we go outside and then divide by 3. Okay, so it is 41 degrees. If you want to round it up, you can also change the setting once for all. So it's 41 degrees, okay? So this, of course, I should, if I want to be precise, I have to write 41 degrees approximately, but that's good enough for us. So what we do now, we write the left-hand side. Did I change the camera? Yes. So square root of A squared plus B squared, which is 4. And then I have sine. The box again is x, but this angle is 41 degrees. And on the right-hand side, I have, yes, but this is even simpler might be than this one. Okay, so what's happening? This means that sine x plus 41 degrees is equal to 1/2. And then x plus 41 degrees has two options. Either sine inverse of that number, which I have it in my memory, it is 30 degrees, plus n times 360 degrees, or x plus 41 degrees is 180 minus that number, which is 150 degrees plus n times 360 degrees. And then you move 41 degrees to the left, so x becomes negative 11 degrees plus n times 360 degrees. That is one solution. And then I move 41, it becomes 109, yes? So x becomes 109 degrees plus n times 360 degrees. Okay, and then n belongs to z. So these are the solutions to this problem. Yes? So simple. Now let us go to this lesson today. There is nothing that I can teach you here. These are like word problems. So you need to read this. It's mainly like physics, or because the applications are not in mathematics usually, is within the other subjects. So you need to read the text and then using what is given in the text to you, so then try to set up equations or identities or whatever is needed and use your trigonometric knowledge to solve the problem and answer. But what I recommend you will usually see these questions in the digital part of the exam. And in those cases, try to use as much as you can. Get help as much as you can. You don't need to solve, but it is not possible to just give the final answer. So if you want to solve an equation, write an equation and then say that I use GeoGebra and this is the answer. Okay? But don't just write the final answer without any kind of motivation. So let us actually try to give you two examples. I chose them from actually an Australian book, I think. So let us chew together. Okay, let us solve this problem. The population of grasshoppers after t weeks is p of t equals to 7,500 plus 3,000 sine of pi times t over 8 for t between 0 and 12. Find the initial population, the population after 5 weeks. Okay. So, I don't feel quite natural for this model. The population of grasshoppers. So by the way, what is the essential feature of this function? Essential feature. No, essential feature, for example, of this sine function. Which kind of phenomena are usually modeled by trigonometric functions? Oscillating means, no, more than oscillating is one particular case of one kind of motions. No, waves, periodic motions, or a periodic phenomenon. So does it mean the grasshopper population goes down? Yeah, so in this case, I like Swedish books better because they try to be realistic. But the weakness is that I don't know Swedish, so I didn't want to mess up. Okay, but anyway, this is not a good model, but whatever it is, they take the responsibility, the person. So this shows that the biologist actually was cheating somehow, yes? Because he tried to sell, I don't know, is it sensible? Because it shows that the population goes up, might be the food sources are limited, then it goes down, and then, because some might be it is good, it's not that bad anyway, okay? But it oscillates up and down, yes? So you can cook up some stories for it, yes? And then probably this is the only thing we humans do, yes? We just make stories and fictions, yes? Yeah. Anyway, but it seems, if you think in that way, it seems reasonable, okay? So the population of the grasshoppers goes down, and then the food is limited, so some of them die. And then, okay, what happens then? If some of them die, then there might be the food resources enough. Then they feel themselves in heaven and then go up. And I don't know. So something you can cook up. Okay. But that is our not duty. This is good that you are a mathematician because you don't care. Yes. Biologist team have actually got that model, and then you want to answer these questions. So what is the initial population? So how should I solve that problem? So if you don't mind, let me write the model here. So P of t is equal to 7,500 and then plus 3000, and then you multiply it by sine pi t. So it's already indicating that we are supposed to work in radians. And what can I call this interval? Let us review some words. So when I say that interval, what is that interval here? What is the terminology we use in mathematics for that interval? It's a function. What is that for that function? It's its domain. Okay? Don't push your brain so hard. It's not a very serious thing. Okay, so that's the domain of my function. So it means that I am limiting the domain, because if that is not there, the domain of sine and cosine, we didn't talk about this, but it is immediately when you see the cosine function and sine functions goes from minus infinity to plus infinity, it means that the domain of functions are R. But if you want having a limited version of the domain, you have to mention it. Okay, so the population, the initial population is what? P of 0. Yes? So what is that? It becomes 7,500 plus 3,000, and then you write sine pi, instead of t you put 0, and that is what you have to calculate. Yes? So what is this number? Pi times 0 over 8 is 0, sine of 0 is 0, and then this is gone, this becomes 7,500. Okay? And don't blindly say this number is the initial value or whatever. For example, if the number of population was modeled by a cosine function, okay, can you tell me then what is the initial population? Yes? 10,500, because then cosine of 0 becomes 1. So anyway, when you want to find the initial value, you need to take the initial value from here and put it there and calculate the function. So that would be the initial value of grasshoppers. So the population after 5 weeks. So what should we do? So this is part A, number 1. Part A, number 2. So after 5 weeks, because the time is given in weeks, so you just need to calculate P of 5. That's it. So this becomes 7,500, and then 3,000, and then sine pi times 5. If you don't mind, let me write it in this way, 5 pi over 8. But this is something that I need to put in my GeoGebra. Okay, so let us just do that. So I go to GeoGebra, and then because this is the number of, because this is the number of populations, so it is better to round it up to an integer, because 1.5 grasshopper doesn't make sense, of course. But so let us just do this here. So what I do you think it's better to go to CAS view? I think it is better to switch to CAS view here. Sorry, I go to CAS view. View, and then let us go to CAS view, take these off, and then let me change my setting. I don't want to save it always, so let me make it 0 for the time being. Okay, and then go here. So what we just do, I just write 7,500, yes, plus 3,000, and then I multiply sine, okay, 5 pi, which is 5 and then pi, divided by 8. Okay. Okay. This number is something mathematicians love, but if you present this number to the manager of the team, they will not understand anything unless you approximate it. So you just press. This is the exact value. By the way, it is a nice exercise. Can you calculate it analytically yourself? Sine of 5 pi over 8. This is a good exercise for the people who are actually curious in calculating things. Sine pi over 8, 5 pi over 8 has something to do with this weird number. Okay, it is this number divided by 2. If you want, you should be able in principle to get the exact value. But here in this problem, we don't care about exact values. I approximate it, and I have already set the decimal points to 0. So I don't have any decimal points, so it becomes 10,272. So 10,272 grasshoppers after 5 weeks. So the population has grown. Okay, now let us go back to the question. What is the greatest population size over this interval, and when does it occur? Okay, this is a better question. What is the greatest population size over this interval, and when does it occur? Yes?
I just had a question about
Yes?
the function. I don't know exactly. This is more of a general question, I guess. But if the function for grasshoppers returns, you can only get an approximate value. Is there no way to find an exact function which will give you back the exact number you want?
No, it depends on the model.
Yeah.
Yes.
Like
No, because what they do, they cannot. This is a continuous function, by the way. Can take any value. Okay, so this is a mathematical model, but what they do in reality, probably they count the population of grasshoppers in any way in discrete time intervals, and then they just got some points. If they want to have a better model, they measure the population at more instance of time. But at the end, they have just some dots, and then by looking at the dots and imagine that if we make it continuous, how it looks like, then they will try to find a curve that fits that shape approximately. That is called a model. Okay, you might say that no, this is not this is a crude model, but that's a model, okay? So this is why when you use, the reason that we make it continuous, because we cannot do calculus if I have a function with discrete domain. For example, if I want to maximize and minimize, I need to take the derivative. And the notion of the derivative doesn't make sense if we do not have the notion of limit. And in limit, I send x to some variable continuously, not jumping from discrete values. So one way of modeling this using calculus is taking some model that fits the data as good as possible. And then say that, okay, if this is the model, let us do some work on it. Yes? Do you understand what's happening? Because otherwise, then you have to only generate a formula so that it gives you integers. And then you will be very limited in the tools that you have. There are not that many functions that generate. The only one that I remember right now is the floor of a number, for example. It generates integers. Yes? Okay. Anyway, so what is the greatest population size? And when does it occur?
So sine is supposed to be maximized.
Hmm?
So which is 1.
Yes. So what is the greatest population?
So 10,500.
Yes. In this problem, it is correct, but there is something that you have to be very careful about. Can you see why? Because you cannot just blindly say that because the maximum of sine is 1, so let us replace sine with 1, and I get the maximum of this function. Yes? Yes, can you fix it yourself?
You must make sure that this maximum occurs
in that interval.
Yeah.
That's extremely important, because who knows, might be this, you have this situation, you have your sine going up and down, but might be that interval is from here to here. I don't know, okay? So if that interval is from, so let us say 0, is from here up to here with respect to that function, so the sine function doesn't have time to reach to its peak. Okay, so then that would be the case. But how do you know that this is not going to happen? We can immediately understand, because I would say that my time interval is between 0 and 12, but my angle is this angle. So let us try to see what is happening. I multiply everything by pi over 8. The left-hand side becomes 0. The right-hand side becomes pi t over 8 is less than or equal to, if I multiply this by pi and then divide it by 8, this can be simplified to 3 over 2. Yes? So this angle on this interval sweeps actually this curve. So it starts from 0 and it goes up to 3 pi over 2. So now this is the starting point, this is the final point, so my angle actually traverses this curve. So do you think now I really reached to my maximum value as Google said? Yes, because in the way that I am going here, sine reaches to sine, actually sine function takes its maximum value. That's one way. So that is completely clear. But you need to think about it. Is the maximum, is the traditional maximum of sine, which is 1, is really attained in the problem? If it is attained, you are allowed to use it. Because sometimes, for example, if I make this interval shorter, for example, if I, instead of having that interval to be 12, let us imagine that t is between 0 and how many weeks? So let us make it, for example, 2 weeks. For example. And then if I do the same thing and I multiply everything by pi over 8, what will happen? The left-hand side becomes 0, the right-hand side, so this middle one becomes this, the right-hand side becomes a pi over 4. Okay? So then the angle starts from here, but doesn't have time to reach its peak. It reaches to the middle one. Okay? And then of course, what is the maximum? The maximum is not 1. The maximum is this much. Yes, so this is important to understand the notion or the rule of that interval given. But anyway, because of this reasoning, we are on the safe side, and then what we can do, we can say that okay, the maximum. So the maximum p. So let me write p maximum is indeed equal to 7,500 plus 3,000. Yes, which is 10,500 grasshoppers, that's the number. But when does this occur? It occurs when? It occurs when sine pi t over 8 is equal to 1. Yes? So, it occurs when this is happening. Yes? But then that's what I'm saying. You just put this in this part in the GeoGebra directly. So you don't need even to bother to solve the problem. Yeah. So you go to GeoGebra and then go to cast view and ask solve. Solve. But you need to explain. Okay, I will tell you how. Okay, so here be careful. GeoGebra by default solve equations in X. Solve equation variable, so I want to change my variable to t, so I choose this option. And then I type my equation, sine of pi, I use this pi, it is important, and then multiply it by t, and then divide it by what? 8, and then equal to 1. And then I would say my variable is t, my variable is t. Yes? And then I ask GeoGebra to solve that. It doesn't. Why? Okay, first of all, I want to make it precise. So sorry, I was just doing it. So it still doesn't solve, but do you know why? Okay, I don't know. Okay, might be I forgot to put the multiplication. So let me see. It should be able to solve that. So I put multiplication here now. Yes, so yeah. So be careful. Sometimes whenever you have two letters or two symbols, GeoGebra, if you don't put product, it considers as one thing, okay? Anyway, so this is the answer. And GeoGebra, this K1, K2, whatever GeoGebra provides is just what we denoted by N. So you say that, okay, using GeoGebra, what, according to GeoGebra, t is equal to 16k1, let me write 16n, plus 4. N belongs to z. Okay, so this is the answer. But of course, this answer is all possible answers. You don't want all possible answers. You want those answers within your interval. So, and then n, I cannot put negative values because it will give me negative values for t, but my interval is supposed to be on the right-hand side of 0. So I can put 0, and it gives me the answer to be 4. If I put 1, it gives me 20, which is beyond my interval. So this would be 4 weeks. And that is the answer that you have to provide. So here you have to write this, using GeoGebra, and the answer is done. Okay, so let us go now to the when is the population? They are more or less the same, so if you don't mind, let me solve the second one. So when is the population 6,000? Okay, very simple problem, yes? When the population is 6,000? So you need to write it in GeoGebra in the paper like this. So something like this. T is what? So that P of T is 6,000. Okay? And then what you need to do, you need to write P of T, which is 7,500 plus 3,000 and sine pi T over 8 equals to 6,000. Using GeoGebra, and then let us write the answer. Okay? So I go to GeoGebra here, and I ask GeoGebra solve. I choose variable here as well, so my equation is 7,500 plus 3,000. You don't need to put product when it is a number. And then here, pi, I use this pi, and then multiplication, and then t, and then divided by whatever that is, 8, equals to what? Equals to 6,000. And then the variable here is t, and then I press enter. So I get these two answers. So I write them down on the board. So using GeoGebra, I have two answers. Oh, no, x, t. So t is equal, what is that? 16n minus 4 over 3. And the other option is 16n plus 28 over 3. N is an integer. So you write that, and then you need to convince yourself what is the correct answer. So I need to find all solutions. I need to find all solutions which are within that given interval. So do you think I can get any solutions in appropriate range from here? No, yes, because if I put negative numbers, it becomes negative. If I put 0, still it becomes negative. If I put 1, it becomes 16 minus 4 over 3. But 16 minus 4 over 3 is beyond 12. So no solutions. Yes? But what about this one? Can I put negative value? No, because it becomes negative. Can I put 0? Yes. Is this in the range? Yes, 28 over 3. So, but this is a little bit strange weeks, you know. So, if you want to have a better answer, might be you can round it and say these weeks as these many days or something like that. But that's up to you how you want. That is, I think, acceptable here. Yes, is that clear? So it was nothing actually. Let us go now to the next problem. During what, this is a better question. What time intervals? Because does the population size exceed 10,000? Okay, I want to wait for you to solve this part. Use GeoGebra to solve this part effectively. During what time interval or intervals does the population size exceed 10,000? If you like to, you can use graphical view. Might be, it's also a good option. So I want to have the number of population greater than or equal 10,000. So instead of P of T, I write this, and then I want to solve this inequality. So let us see, by the way, we can use graphical tool to solve it or not. So let me just type things in. It is y equals to 7,500, and then plus 3,000, and then I have sine of pi multiplied by t By the way, the weakness of GeoGebra is that if you want to do the graphical view, you have to put X, I think. Okay, so instead of T, I put X, then I go to 8. And I will have a little bit of problems here. Yes, you cannot even see that. This is reasonable because it starts with 3000 or something. So let us squeeze this as much as we can. Yes, now it is coming down, okay? So this is my graph and it is automatically in radian mode. Yes. Okay? And then what do I need to do? I draw the horizontal line y equals to 10,000. This is the horizontal line. And I think it's a good idea. So you can immediately see it. We don't need to make it more beautiful, yes, because it is already good enough. So you see the population is this, the population. So I drew this. This is the green curve. This is the horizontal line. I rescale the y-axis because the numbers on the y-axis are so big. And then this is 12. So if you don't mind, let me draw x equals to 12. Make it sure that we understand. Okay, so this is the limits of my function. You see this rectangle that you see here. Okay, I want to know that within not within the rectangle. Sorry, within this interval from 0 to 12. You see this part, the graph is above the 10,000, and that is the interval. So what I go and use this intersect, and what I do, I intersect between these two, I get a line. It doesn't give you all of them. You have to ask it nicely, okay, one by one. Okay, so one of them is 2.51, the other one is 5.49. So this number that you see here, this number, yes, I cannot draw a very nice line here, but this one up to that one, okay, it's like a drunken line. Anyway, so this is where this is happening. It is between 2.51 and 5.49, and I don't know, so let me change the setting to whole numbers. It's better. Okay, between 3 weeks and 5 weeks. Okay, so this is much easier to solve using graphical tool. Is that clear? Yeah, so you need to answer. I put it in GeoGebra. Using GeoGebra, I will have this answer. So between 3 weeks and 5 weeks. If you want to make it more precise, you need to add more decimal points. But let us test this idea. If GeoGebra is capable of solving inequalities, it is capable of solving algebraic inequalities, but I don't think it will be able to solve trigonometric inequalities. So let me choose cast view and take off these two, and let me solve. And I think solve is the same command. So I use solve equation, even though there is no inequality, but let me choose this one. So 7,500 plus 3,000, and then I would write sine of pi times t, and then divided by 8. Okay, and then greater than or equal to, so greater than or equal to is where? It's here. Greater than or equal to 10,000. And the variable is t. I don't think it will be able, no. As I expected, it cannot solve trigonometric inequalities, yes.
Since this is I was just thinking because for a sine function, you'll have two values where because we want the second part to be 2,500 or greater, right, to get greater than 10,000.
Yeah.
So if you find the two roots, I guess, for where t.
Yeah, I mean, analytically you can solve. It's not hard. You move it to the other side. It becomes 2,500, and then you divide by this number. So this becomes sine pi t over 8 is greater than or equal to 2,500 divided by, yes, 5 over 6. And then you need to understand that, okay, if I draw this circle, Let us say this point is 5 pi over, this is 5 over 6. And then I draw a horizontal line because sine is the y value. Okay? So it means that I have to start from here up to here. So it means my angle is somewhere here, and then it continues up to here. So if you want to solve it analytically, you can do that. So what do? This angle is what? This angle is sine inverse of 5 over 6. So it means pi t over 8 should be greater than this one. But up to this point is pi minus sine inverse of 5 over 6. If you really want to solve it analytically, and then you multiply by 8 over pi, so then you will find the interval for t. So you only need a calculator to calculate this. Yes, that's correct. But I just want to tell you that usually this comes in that part that you can use GeoGebra, so use it efficiently while you want to spend time on it. Okay, so that's it. If I go back to this question, let me ask the question. I want to give you time to find this one yourself. It's a little bit harder one. Okay, let me see. Yes. So I want to wait for you so that you can. A paint spot X lies on the outer rim of the wheel of a paddle steamer. The wheel has radius 3 meters and rotates anticlockwise at a constant rate. X is seen entering the water every 4 seconds. H, capital H, is the distance of X above the bottom of the boat. Where boat is? Okay. Okay. At time t equals to 0, X is at its highest point. Find a cosine model for H in this form. Part B, at what time t does X first enter the water? It's a better question, so yeah. I want to wait for you to think about it a little bit yourself. So because we don't have that much time, so let us try to solve the problem. But let us use physics to solve it a little bit differently from mathematics. So if you want to solve it using physical way of thinking, so you know that this is a periodic function, yes? So you can say that, okay, I have this height. This height is from here to here, and then plus 1 meter. Okay, so I can write height at time t. So I don't know, let me just try to give you an angle. So let me call this angle theta. Yes? But this angle is a function of time, because when this rotates, this angle increases, then it actually rotates. So how can we solve the problem? I can say, let us write this as, you see, if I want to find h as a function of time, h of t is what? Can you tell me? You see, h of t is from here to here. It means from here to here. So from here to here is 1 meter. But from here to here is the radius, which is 3, plus 3 times cosine theta. Yeah, is that understandable? So what I'm doing, so you see from here to here, I myself call this angle theta. From here to here, this is the radius 3, so this becomes 3 cosine theta. From here to here is 3 cosine theta, from here to here is 3 units, and from here to here is 1 meter. So if I ask you what is h of t, it is 3 cosine theta plus 3 plus 1. So h of t, why h of t? Because theta is a function of t itself. Okay? So h of t is equal to 3 cosine theta of t plus 4. So if I take this theta, then I can understand my model is a cosine model. Yes? But the problem is, what is theta of t? So do you know, have you seen this in physics? Theta t, if omega is constant, you can write it as omega t plus omega naught, yes? Have you seen these formulas in physics? You haven't studied that yet? No, the constant term is, the constant, sorry, yes, you are right, you mean this.
I mean, we haven't had.
The reason is that this insect is killing me, okay? So theta t is this one. The reason that you don't have it because might be at the initial time you are at 0. Okay? But in this problem, when we start the experiment, it is not at theta 0. So it means that theta 0 is the initial value of my theta when this was there. Okay, but what is omega? Omega in physics is 2 pi over the period. Yes? And the period, according to the problem, is 4 seconds. Yes? So this becomes 2 pi over 4, which is pi over 2. So if I put it here, then it means theta t is nothing except pi t over 2 plus theta 0. And then I put it back there. But then I need to find theta 0 myself. So h of t becomes equal to 3 cosine, and then I have pi t over 2 plus theta 0, and then plus 4. Okay? This is you can use physics to solve the problem. Yeah? But now can you tell me what theta 0 is in this problem? Theta 0 is something that can be fixed by my initial conditions. So what is my initial condition here? Do you have any information? No, I mean, h is the distance of the x from bottom of the, okay. At time t equals to 0, x is at its highest point. So theta 0 is indeed 0. Yes? Because when you say time is 0, this point is at the highest point. Yes? According to the way that I defined my theta, at time 0, theta is 0. So theta 0 is 0. So that is it. This is my model. Yes? It does make sense? So what I did, let me repeat something again. So in physics, I call this theta. I know this is not fixed because this is moving around. So theta is a function of time. But let us call it theta. And let us try to find h in terms of theta. It is not that hard. Because from here to here is the radius of my circle, which is constant 3. From here to here, it's given in the problem, which is 1. The only thing that is changing is this part. And this part is simple because this is a right angle triangle, this is the adjacent side, and this is the hypotenuse. So if I want to find the adjacent side, I multiply the hypotenuse by the cosine, it becomes 3 cosine theta. So if I ask you what is h of t, you will tell me 1 plus 3 plus 3 cosine theta. Why you see time dependence? H depends on theta, but theta itself depends on time, so I can say h depends on time. Okay, but what I did, I have this formula in physics. Why can I use this formula in physics? Because this can be used if omega is constant. Why do I know omega is constant? It is mentioned. It rotates at a constant rate. So I can use these formulas. Okay? So the only problem here is that, by the way, I could immediately write this. Why is that? Because it is mentioned that when you start the experiment, this point is at the highest point. So initially this point is here. When it is here, theta is 0 when it is here. So this means that when t is 0, theta should be 0. So it means theta 0 is 0. And you put it back here, and then you get your answer. Another thing that I calculated is my omega. Omega, you have it in physics, 2 pi over t. T is 4 seconds, according to the problem. I put 4, it's pi over 2. So that is your model. Yes? You can, of course, use geometry. So it's making it more complicated, okay? So this is our model. And now if I go to the problem, at what time t does x first enter the water? What does it mean? It first enters the water when h becomes what? 2. H should be 2, because when this point goes into the water, h is this much. Yes, and that becomes 2. So what I do, I would write for which time h of t is 2, and then try to solve the equation. So this becomes 3 cosine pi t over 2 plus 4 is equal to 2. So let us use GeoGebra to solve that. So I go here and I ask GeoGebra, so let me take this off. I solve that one is 3, and then I multiply it by cosine, and then pi t. So this is pi times t, and then divided by 2, and then I go here and plus 4 equals to 2, and the variable is t. Oh, it gives a very horrible answer, but no worries. We put approximations, it becomes simple. Yes? So these are the numbers that I get in GeoGebra. Yes. So let us go back here. So these numbers are exact numbers, but these, if you put approximations, I get 4n plus 1, 4n minus 1. Okay. So t is equal to 4n plus or minus 1. But what is the first one? Okay, so you need to know, because all of them are acceptable. It will repeat itself over and over again. But I want to see what is the first one. So the first one is the first positive one. So you need to do this. You have 4n minus 1. Let us generate some of them. If I put minus 1, it becomes minus 5. And then if I put 0, it becomes minus 1. If I put 1, it becomes 3, and etc. So let me put 2, it becomes 8, 7, and etc. And for the other one, 4n plus 1, if I put minus 1, it becomes minus 3. If I put 0, it becomes 1. If I put 2, it becomes... If I put 1, it becomes 5, etc. So what is the answer to the problem now? 1. Because in this list, the first one is 3. The first positive one in this list, the first positive one is 1. I want the first time that it happens, and that is 1. So of course, approximately. Approximately after 1 second, this is that. But that number given by GeoGebra is the exact answer, of course. Okay, so I think this is a good starting point. Any questions? So there is one very simple thing left from the whole geometry, the trigonometry chapter, and that is the graph of tangent of x. Next time that we meet after the break, I will do that part, and this geometry part is finished. Trigonometry part is finished. No questions? Yes?
Will we do calculus with trigonometry after this week?
Yes, we start the notion of derivative. Yes. And then after that chapter is finished, we will have our main first exam. Yes. Thank you very much and have a nice holidays.